Hello and welcome to Introduction to Stata. My name is Chip O'Connell. I am the graduate assistant for KIPSR at the University of Kentucky. KIPSR is the Quantitative Initiative for Policy and Social Research. Throughout the school year, we provide workshops on quantitative methods and statistical software, and we also bring in guest speakers from other universities and other things like that. Most of the time, we would be doing a presentation such as this in person, but with the recent COVID-19 situation, we have decided to make some videos so that UK students and faculty can continue their education on statistical software while social distancing and spending some time at home. If you're interested in learning more about KIPSR, you can visit our website right here at the URL listed right here, kipsr.as.uky.edu. We will hopefully have in-person workshops in the fall of 2020, hopefully. So if you want to check out the schedule for that, please check out the website and keep up to date with our guest speakers and things like that. And with that being said, I'm going to jump into an introduction to Stata here. And before I jump into all of this code and stuff here, I'll talk just a little bit about what Stata actually is. And so Stata is a statistical software. It's a software that's capable of handling fairly large data sets. And as far as statistical softwares go, it's kind of a happy medium ground between something like between a program like R that's almost entirely code-based and a program like SPSS where you are mostly using drop-down menus and the graphic interface. Stata is, again, a nice happy medium where you can use both code and the graphical interface. And if you use the graphical interface and the drop-down menus, it will actually spit out lines of code that you can then copy and save for later. Within Stata, there are three main windows. The first window is the window that you're looking at right now, and this is pretty much the main window. It's the window that you will spend most of your time when working with Stata in. Within this main window, there are several consoles. The first console we can look at is this one right here. This is the output or the results console. The results of any commands will be posted right here. Any type of statistical analyses we run, the results will be posted right here. And this is where our main output will be listed. The next console to look at is the command console. Right here is where we can type our commands. We can type commands here. As you can see, when I type a command here and hit enter, I get a result in the results window. And this is an invalid command, so it gives me an error. This was a valid command, it would give me something that was not read. It would give me the results of a valid command. The next console to look at is this history console. This lists all the previous commands that I have listed that I have used in this session of Stata before I close this session of Stata. This is really handy because I can click a command here and it brings it back to my command window, which I can then hit enter, or I can just double click the command here and it will rerun the command. That comes in very useful when you need to run a command over and over or something like that. And then one more console to look at here in the main window is this variables console. Once we have some data loaded in here, all of our variables will be listed right here in the window. And we can search for a variable right here. And we can also use this window right here to find some more information on our variables, as well to change the nature of our variables a little bit. We'll talk more about that later. The next window we need to look at is the data browser window. So we can find that by clicking this little icon right here. If we click that, we get this spreadsheet that comes up, and once we have some data uploaded, we will see all of our data laid out here in a spreadsheet in this window. I will say that right now we are in browse mode. So if I try to click here and enter in some data, nothing will happen. If I can switch to to edit mode. And if I switch to edit mode by clicking right here, I'll get this prompt. I'll click yes. And then I can enter data here. I can enter stuff here and save it. But most of the time, you're not going to want to do that. Most of the time, when you make changes to your data, you're going to want to do that through commands. And so you're going to want to switch back to browse mode most of the time. And when we make changes to our data, most of the time we're going to do that through commands, and we're going to want to do that through commands that we save in our do file, which is the next window that I want to look at. The third and last window is the do file window. And so this is the do file. This is where we can type all of our commands and save them for later. So we can put all of our commands here. We can save this. We can close Stata, go do something else, and then come back and open this back up, and all of our commands and all of our work will be saved in this window. So you can type commands here in this command window, but most of the time, you're going to want to type commands in the do file, or if you do type commands here, you're going to want to copy and paste it from the results window and paste it into the do file so that you can save it and have it for later use, and you can go back and edit your work and look at what you did and things like that so that you can save your work. Now I'm going to close this do file because I already have another do file open that has a bunch of commands that I have saved, and we can go back and go through. So we can jump right into Stata now. And one of the first commands that I want to talk about is the help command. So, the help command is definitely your friend here. We can just run. I need to say this. In order to run a command from your do file, we can just highlight it here, and then we can hit this execute button here. So if we run the help command, it brings up this general help advice, just general advice on how to use Stata. But we can also look at more specific commands. So say, for instance, that we want information on how to run a regression, a linear regression in Stata. The command for that is regress. And so to find out more information about that, we can go to help regress. And it'll give you all types of information about the regress command and how to run it and all the options that you can specify with that command. A couple other things I want to say is that we have made this video to kind of give you a general introduction to Stata with the hopes that you can kind of watch this video and then jump right into manipulating and messing with some data yourself. But if you've watched this video and you're looking for more information, the company that makes Stata actually has their own YouTube channel, and they provide a lot of videos, a lot of detailed videos on how to do pretty much any command in Stata. And so if you want to get some further information after this video, you can visit this website, this URL listed right here, youtube.com/user/statacore. And then another thing I'll say is if you have any type of question regarding Stata, the online Stata community is extremely helpful, extremely informative. If you have a question, I would almost guarantee that you can Google that question and you will find someone who has already asked and answered that question on the Stata forums. If you can't find that question, you can make a username and you can make an account on the Stata forums and ask your question, and I can almost guarantee that someone will answer that question within a day or two. You can find the Stata forums at this website right here, statalist.org. Again, you can search the website without making an account. If you want to make a post, you have to make an account, but it's really easy to make an account. And again, if you have any questions, if you post it, it will get answered very quickly. The online Stata community is extremely helpful, so visit those forums if you have any other questions. All right, now turning to some actual commands. Before we really start doing anything, I want to go over these helpful commands to start with here. Before you start doing anything, you might want to specify which version of Stata that you're using. So I'm currently in the newest version of Stata, Stata 16, but you might want to revert back to an older version of Stata. Maybe there was an old command in an older version that you like to use that didn't get brought over to the new version of Stata, to a newer update of Stata. But that's okay because you can always revert back to an older version. And so we can run this version 15. That will revert us back to version 15, and any commands that were in version 15 will run the same way as they did in version 15, even though I'm technically in version 16 here. All right, so that's always a useful command. The next command that you pretty much always want to start off with before you start looking at any data is the clear command. So if I just type clear, it will clear all the variables that I have loaded and all the variable labels and things like that. But if I type clear all, it clears all variables and labels, all stored estimates, basically anything that you have stored in Stata's memory at the time, it will clear, and you're basically starting off with a fresh blank slate. And so I always recommend running this before you start doing anything, just to make sure there's nothing clogging up your memory or messing with anything that you might not want to be happening. So we'll always run this clear all command to start with. I believe the set more off command is useful. So a lot of commands and analyses that you run in Stata will pump out a lot of information that you might not necessarily be interested in. You might want to see it if you really want to get a detailed look, but normally you might not really be interested in that information. And so if you want to save some computer memory and save yourself from having to wade through a bunch of, I don't want to say useless information, but information that you don't need at the time, we can go with set more off. So we'll run that command. If you want to see that information, you can always go back and type in set more on, but for now we'll go with set more off. Okay, now these next two commands are really important, and so I'm going to spend a couple of minutes talking about each of these. And this first one's really important, and it's your directory command, your change directory command, CD here. Your directory is where all files are going to be saved if you try to save a file in Stata. It's where Stata will automatically go to look for files if you don't specify a file path. It's any type of anything you save or store or try to draw from will be saved in the directory. So you really always want to specify a directory so that you know where your files are going to be saved at, and so that you can know where to tell Stata to look in order to find them. So I'll talk more about this later, and it might become a little bit more clear once we use it. But let's go ahead and run this. So I'm going to change my directory CD to this folder on my desktop called Intro to Stata Workshop. I can show you this if I come down to my File Explorer, open that, go to my desktop, and then I have Intro to Stata Workshop. And so this is where I have all the files. This is where I have this do file saved. This is where I have various data files that we will use in this presentation saved. And so I can draw them right out of this folder without having to type the whole file path. All right. In order to get that file path for the directory, you can click right here, and then you can just copy and paste this, put it here after the CD command, and this, if I run this, it will make that my working directory. Okay. Another really useful command is the log command. A log is similar to a do file, but a log saves all of the output. Whereas this do file will save all of the commands and all of the work that we did. This log will save all of the output that we save, everything that pops up in this output window. Okay, and this can be important so you can always go back and check your work, make sure you're reporting the right statistics and that Stata is reporting it the right way, and things like that. So we always want to run a log command. So we're going to tell Stata to run a log using this file name that we're naming workshop log, to create a new log file named workshop log. And then we're going to use the replace command in case we want to come back and work on this do file and run a different log later. Save that log and replace the old workshop log. So we'll run that. That starts a log. So now all of this output that you see here will get saved in this log file, and we can go look at it later. All right. If you want to start messing with some data in Stata, you're going to need to get some data in. There are multiple ways that you can bring data in. one of the easiest ways to just draw a Stata data set right off the internet. Some websites have Stata data sets listed. In order to bring in a data set that way, we can just use the use command, and we're just going to type use the URL where the website or where the data set can be found. So if we run that, it'll bring in this data set. We can go to our data browser. I should have said this earlier. We can get to our data browser by typing browse, and we can shorten that to just BR. So we can type BR, and that will bring up the data browser. And as you can see, we've brought in this data. This is a simple data set looking at the weight of apple trees and what kind of treatment they received. That's just a simple sample data set. But that's one way to bring in data. And another way, and so it might not be a Stata data set. So that's what this .dta file is. That's a Stata data set. Most of the time, you won't be bringing in Stata data sets. It's going to be a CSV file or an Excel file. And so we can draw those right off of the internet too. In order to do that, we're going to go with the import command. And we're going to say import delimited. We want a delimited text file. And the URL where you can find it at. And this is kind of important. We're also going to say comma clear. Again, this clear will clear out this old apple tree data set to make room for this new data set. So we will run this. All right. This data set is a data set on military coups that was found by Clayton Tyne and Jonathan Powell. We can browse this, and you can see that we have country codes, year, and whether or not a coup occurred in that country in that year. Now, most of the time, though, you're not going to be bringing data sets in right off the internet. Most of the time, you're going to have an Excel file or a text delimited file saved on your computer, and you're going to want to import that into Stata from your computer. And so the way to do that is with the import command. And so we can just say import delimited workshop.csv and then clear the previous data. So if we run this command, we run it, it runs, we can browse, we can look at our data. Here's all of our data. What I want to specify here is that the only reason we could tell it to import this file, this workshop.csv file, is because Stata knows to look in my working directory for a file called workshop.csv. And so if I show you this working directory, go to my desktop, intro to Stata workshop. See, I have a workshop.csv file in this working directory that I specified. If I didn't specify this working directory, or the data set that I was looking for was in a different folder, then I have to specify the entire file path. And so I'll show you what that looks like, because another way that we can import data in is with the graphic interface or with the drop-down menus. And so I'll show you how to import data this way. To do it that way, we're going to go to File, Import, and this is a CSV file that I'm trying to import. So I'm going to go with text data, delimited CSV. I'm going to browse for the data set. I'm going to go to my directory. And this is the file that I'm looking for. So I can open that up. You usually want to specify that the first row should be variable names if that's how your data is set up. And we'll run that. And if we run that way, see, it spits out the code, import delimited, the entire file path. So if we want to, we can copy and paste that and put it in our do file. But because we've specified our directory and we have this file saved in our directory, we don't have to put this whole file path. We can just say import delimited, look for this file, workshop.csv, comma, clear any old data to make room. And it makes for a much simpler code than putting the whole file path. So again, that's why your directory is so important, because it makes for a clean do file, makes for clean code, where you can just put simple file name and not the whole file path. All right. We can also maybe have an Excel file, not a CSV file. The way to import that is import Excel workshop.excel file. You want to specify which worksheet you're working with. Again, first row are variable names. You want to specify that, and clear any old data. So clear any of that. We can run that. And again, just to show you real quick, you could do that with the drop-down menus, import Excel spreadsheet, and it's basically the same system. All right. And then so we can save this as a Stata data set, and it'll become a .dta file. And once we do that, we don't have to import anymore. We can just use, and so we can just say use the file name clear, and that's a Stata data set. That's how you bring in a Stata data set as opposed to like an Excel file or a CSV file. All right. So that brings in this workshop_A data set. Now I'm going to talk about how to merge data. And so if we look at this workshop A data, you can see that it has an ID variable that is a unique variable for each student in a school. And it also lists the student's gender, their race, socioeconomic background, school type, which is either 1 for private or 2 for public, and what type of program it is, if it's general or vocational or an academic program. Okay. But the point I want to highlight here is that we have this ID variable that is a unique identifier for each student in this data set. Okay. Now say that we have another data set that has test scores for those students, and we want to merge those two data sets together so we can run a regression on a student's socioeconomic status and race on their test scores. Okay, so in order to do that, we're going to need another data set that also has that unique ID identifier. All right. One thing I want to show you before moving in this is something new in Stata 16 is that you can have multiple data frames. Right. And older versions of Stata, you could only bring in one data set at a time, and then you had to clear it to bring in another data set. In version 16, you can actually have multiple data frames loaded at the same time that you can switch between. And so we'll do that. Let me show you how to do that. In order to do that, you're going to specify the frame or the command frame. You want to create a frame, and then we're going to name it frame 2. You can name it whatever you want. This is the name of the new frame that you specify. So we'll create that new frame, frame 2. And then we're going to tell Stata that we want to change to the new frame, frame 2. And then we're going to tell Stata that in this new frame 2, we want to use this data set that I have in our directory called workshop B. And so we bring that in. Now we can go and look at the workshop B data. And again, this also has the unique ID identifier. That's this unique identifier for each student. And then it has the student's test scores. Right. Now, we're going to use this unique identifier, this ID variable, in order to merge these two data sets together so that we can compare test scores to students' socioeconomic status, race, and program type. All right. So in order to do that, we're going to change back to our default frame. Okay. So change back to default frame where our workshop A data is saved. We can look. Here's our workshop A data. And then we're going to tell Stata to merge one-to-one using that unique ID variable, that variable ID, using this workshop B.dta data. So if we run this, we can see that all of our observations matched. All 200 students in workshop A had matching test scores in the workshop B data. I'm going to take just a second to show you how to do that with the drop-down menus. And again, I want to highlight that the only reason that we can just say using the file name workshop B is because this is in our directory that we have specified. If this is not in that directory, or if we've not specified a directory, we have to use the whole file path here. And just to show you how to do that, we would come up to data. Actually, let me clear this, and then we will use workshop a.dta. Okay, so now I have the original workshop A data set brought back up. In order to merge that with workshop B, we can come up here. You go to combine data sets, merge two data sets, and where you're going to want one-to-one. The key variable to match on is that unique ID variable. And then we're going to browse and we're going to find in our directory here this workshop B data. We'll click on that, open that. And if we run that, this gives us the same exact results as doing this command. It also spits out the code. Again, the only difference here is that this gives us the whole file path, so we can copy and paste that. Whereas here, we had a directory specified, so we can just use just the file name. We don't need the whole file path, just the file name. Okay, so now that we have some data imported, we've merged in maybe some control variables or something like that, we can start to manipulate our data and look at our data and get ready to start to analyze our data. So we've already gone over this browse command. You can also use the edit command. If you type in edit instead of browse, it will open the data browser in edit mode. So we can go ahead and edit these things. But again, I like to always stay in browser mode. If I want to change my data, I will do that with commands in my do file. We can also sort by variables. So if we look, let's look right now. If we look right now at the race variable, well, this data set's actually already sorted by race. So if we look, it's already sorted by race. So all the Hispanic students are together, all the Asian students are together, all the African American students, and all the white students are together. So it's already sorted by that. So instead of sorting by race, I'll show you, we'll sort by socioeconomic status. So if we run that, you can see it groups your observations by the variable that you specify so that you can look at them by group. Okay, so now all the middle SES students are together, all the high SES and all the low SES are together. All right. The order command is also useful. So right now, the first variables are gender, ID, and race. Say we wanted to change that, we can use the order command. If we say order, gender, read, and write, that brings the gender, read, and write variables to the left of the screen to make them easier to look at. Another useful command is this miss table command. Sometimes we want to check to see how many missing observations we have. So we can say miss table sum and specify all. It will show us all of our variables. And so if we look here, science has 5 missing variables. There's only 195 observations for science, but all of our other variables have all 200 observations. The describe command gives us some information about the nature of our variables, the way they're stored, their current labels, things like that. And we can also run cross tabs. So if we tab a variable name, so we can look at tab gender, this will give us a cross tab of gender, which shows us that 91 of our students are males and 109 of our students are females. We can also do a bivariate cross tab. So if we look at that, that will break down gender by race. And so 13 Hispanic students were male, 11 were female, and so on. Maybe you don't want to look at your whole data set. You just want to look at the first few observations so you can get a feel for it. So we can tell it to list a variable. In this case, we're going to say list all variables between gender and read in 1/10, which means I want to see the first case through the 10th case. So the first 10 observations, first case through the 10th case. And it'll show us all variables through gender through read. So it shows us gender and read and the values for the first 10 observations. The summarize command is a very, very useful command. If we run the summarize command, it will give us descriptive statistics of all of our variables. It'll give us the mean, standard deviation, the min, and the max for all of our variables if we just type summarize, but we can also type summarize specific variable names. And then we can also specify detail. If we run it that way, it'll show us more detailed descriptive stats for each variable that we list. And so instead of just showing us, the mean and the median, it's showing us percentiles and a little bit more detailed information than just the regular summarize command. We can specify that we want descriptive stats for only observations that only students that have a reading score above 60. In that way, so we would say summarize if reading is greater than or equal to 60, and that'll give us summary stats only for students above a reading score of 60. We can summarize all students from the academic program type. And then we can just summarize one variable at a time with detailed information and find their percentiles and things like that. And we can also tell Stata that we just want percentiles of a specific variable with the centile command. That will give us percentiles here. And we can also use the codebook command, which will give us, again, percentiles, how many missing units we have, there's just various information on the variable. So now that we've looked through our data that way, we might want to look through our data graphically. So we might want to start by just looking at a couple of histograms of our data to see how our variables are distributed. A way to do that is with the histogram command. So we would just type out histogram and the variable name. So histogram read will give us a histogram of the read variable. The graph we just looked at was a density plot. We can specify that we would like to see a frequency plot instead by saying hist read, frequency. And we can also tell it that we would like to see a normal curve drawn over the distribution so we can compare it to a normal distribution. And you can see the normal command gives us this normal line, and we now have a frequency distribution rather than a density plot. Okay, sometimes we might want to look at transformations of our variables. A lot of statistical models call for normally distributed variables, and sometimes we might want to transform a variable so that it's normally distributed. And in order to find which transformation is the closest to normal, we can use this ladder command. So we can look at ladder read, and it will give us information on all the transformations of read, such as the square of read, the cube of read, the square root of read, and things like that. And basically what you're looking for here is a low p-value. If it's low, then we can say it's normal, and we can use it. We can also look at that graphically with the G ladder command. So we can say G ladder read, and if we run that, it'll show us which is most normally distributed. So the log one looks pretty good, and you can see which transformation of the read variable is the closest to normal to include in your analyses. And we can also use the Q ladder command. The Q ladder command gives us a plot of the power quantile versus what a normal plot should look like. So basically what we want to see here is we want to see it follow a straight line. We want to see which one most follows this straight line. The straighter it is, the closer to normal we say that it is. Okay. Now we might want to look at the relationship between two or more variables. We want to look at the relationship between all of our variables, to get a quick overview, we can use this graph matrix command. So if we specify graph matrix, all the variables that we want to see, it will give us this kind of correlation plot. So this one right here is the correlation between math score and reading score. This one is correlation between math and science score. This one's science and writing score, and so on. When I run this command, I really like to specify the half command. I think that makes it a little bit more understandable, a little bit easier to understand if we run it this way, but that's up to you. And now if we want to look at the relationship between just two variables, we can run a two-way scatter plot. The best way to do that is by saying two-way scatter and then our two variables. So we want to scatter plot between math and read. We're going to say two-way scatter math read. So we'll run that, and that gives us this two-way scatter plot between reading score and math score. If we don't want a scatter plot, we would rather have a smooth polynomial line, we can run the lpoly command, and we can also specify CI. That will give us confidence intervals. So we can run that to look at this relationship in a smooth line instead of a scatter plot. And we can also combine those two graphs. So we can have a scatter plot and the local polynomial line. The way we do that is by saying two-way scatter write and read, and then these three slashes are just to break up this line so it won't be as long. But so we're going to say two-way scatter write read, and then in another parentheses lpoly write read, and this command will combine the two graphs that we just looked at. All right. But I just want to emphasize that these three lines are just to break up the line so that it's not as long. But we can take that out and run it. And I also want to specify CI here. So we can take that, run that, and it gives us the same line, okay? We can also break these variables down by a third categorical variable. So we can say that we want to see a two-way scatter plot from write and read, and then we want to see this local polynomial line for different categories of race. So if we run that, it'll look like this, which is okay, but it's kind of messy. To make it in a little bit cleaner way, we can specify that we want a two-way scatter plot between write and read, and we also want the local polynomial line between write and read. But this way we can specify by race. And if we run it this way, it will give us different graphs for each category of race. And it's a little bit cleaner of a way of looking at it than the last one was. And then with Stata graphs, you can get pretty fancy, giving them titles, changing the colors and things like that. So for instance, we can run this really long line of code, and it will spit out this graph. It's a nice looking graph. It's easy to read. We'll go through it real quick. So first of all, we're saying we want a two-way scatter plot between write and read. We want the marker color to be forest green, and we also want a plot of an LFIT line between write and read plotted over that, and we want the line color to be blue, and we want the line pattern to be solid. And then we specify by. This line of code is a little hard to explain. You have to put this parenthesis, comma, space in order to have the title here. It's honestly a little hard to interpret, a little hard to explain, but that's the code. And then title, parentheses, reading score, subtitle, broken down by socioeconomic status, and a note. Right here, our note is right there. And so that breaks down this graph right here. As you can see, that line is kind of complicated, and you might not be able to remember that. And so what I want to stop and talk about here is that personally, when I'm making graphs, I really like to use the drop-down menus to make graphs. So we can recreate this exact graph using the drop-down menus, and I'll show you how to do that really quick. So if we want to recreate, this line of code that we just ran to recreate that graph, we're going to come up to graphics. We're going to go to two-way graph. And the first thing we have to do is specify the first plot, the scatter plot. So we're going to create a plot where it's a scatter plot. Y variable is write. X variable is read. The M color was forest green, so we're going to go to marker properties, change this to forest green. Okay, so we'll accept that, and that creates our first plot. All right, now we want to create a second plot that's an L-fit line between write and read with a blue color line, solid line. So we're going to create another plot definition. We'll go to fit plots. We want a linear prediction. That's the one we want. Write Y variable, read X variable. Then we're going to go to options. We want line properties. We're going to specify that we want the L color, the line color, to be blue. And the pattern was solid, so we'll specify solid. And then we also have this C missing. That's fill. We'll accept that, accept that, accept that. That adds our second plot. And then we want to specify we want subgraphs for unique values of variables, and we want to specify that it's a socioeconomic status variable. And then finally, we want to get our titles in here. So our titles are reading scores by writing scores. The subtitle was broken down by socioeconomic status. There was no caption, but there was a note that says the blue line is a fitted value. And so if we run all that, we can now hit OK. It'll run it. Gives us the same graph that we just looked at. We can kind of compare these two lines of code. And if I did everything right, it should look pretty much exactly the same as that line of code. And so I just want to kind of highlight that you can make graphs using the drop-down menus and the graph editor, and it'll spit out a line of code that you can then copy and paste and put in your do file to save for later. You can come back and edit it later if you want. So I find the drop-down menus to be very useful for making graphs and charts and things. And it will spit out that line of code. Make sure you save that line of code so you can always come back and recreate it later. All right. Now that we've looked at our data, we've examined it, we know what it looks like we might want to start modifying it. So the first thing we want to do is get some metadata on there. Maybe we want to send this data to a co-author so they can look at it, and they don't know what these variables mean. They don't know what SCHTYP means. So we're going to put some metadata on here to better define our data. Okay, and so if we look here, right now only a few of our variables have labels. So for instance, this SCHTYP variable, that's a school type variable, but it's kind of hard to know that because it's not labeled. So let's label that variable. How we're going to do that is we're going to say label variable name school type, and we want to call it type of school. So if we run that, we can go back, and now SCHTYP is labeled type of school. Now, if we codebook school type, we'll see that it takes the values of 1 and 2. But someone who has never messed with this data before has no idea what the values of 1 and 2 mean. So we want to change this to private and public so people will know. In order to do that, we're going to say label define. You can call this whatever you want. Right now, we're going to call it school type 1, SCHTYP 1. And this label definition, SCH type 1, is 1 equals public school, 2 equals private school. So we'll run that. And now we're going to tell Stata to take or use the label values, apply it to this variable, the label definition that we just defined. So label values, the variable the label definitions that we just defined up here. So if we run that, now we can come back and codebook our school type variable. And now we see that 1 is labeled public school, 2 is labeled private school. So anyone that's not familiar with this data can look at it and know instantly what that school type variable is. We might want to rename a variable. The way we do that is with the rename command. So we're going to rename the gender variable and we're going to call it female. So we'll do that. And we now see that this gender variable has been renamed female. Sometimes you might want to generate a new variable based off of old variables. So for instance, you might want to transform a variable. The way you would do that is so say you want to take the natural log of a variable. The way to do that is with the generate command. So we're going to say generate this new variable name that you specify. We're going to call it ln_read for natural log of read is equal to ln, the natural log of the read variable. So if we run that, we can go look at our data, and that has added a new variable called natural log of read to our data set. Another thing you can do is you can add two variables together. So you can generate new variable is equal read plus math. So that will add the read and math scores and generate a new variable. Any arithmetic or algebraic function you can type with this generate command. Sometimes you might want to drop some variables. Maybe your data set's just too big and you want to get rid of some stuff to make it easier to get through. So you'll use the command drop followed by the variable that you want to drop. So let's drop the social studies command. This is a useful command. You can generate a set of dummy variables based off of a categorical variable. So we'll say tabulate race, generate a new variable called R that will generate a series of dummy variables indicating what race the student is. So if we do that, that generates new variables R1 through R4 that are a dummy variable. So it equals 1 for white, but 0 for all other variables, or for instance, 1 for African American, 0 for all other variables. It creates those dummy variables. So that's a fairly useful command. This is a really useful command. Sometimes when you import a new data set, it will have characters that Stata does not understand, and we want to kind of clean those up. So this command will do that. You want to replace string equals sub in string and specify the characters you want to take out. It's a useful command. And then sometimes if you import a numeric variable into Stata where some observations are not numerical, it's going to automatically import it as a string or as a non-numerical variable. And so sometimes we want to de-string a variable. And the way to do that is to say de-string the variable name, generate a new variable that's not a string variable but a new numeric variable, and that's the new variable name. So if we run that, we can browse, and we see that the string variable is indeed a string variable. It's non-numeric, but we also generate a new variable called string2 that now takes on a numeric value. And then finally, I'll just show real quickly a few basic statistical tests that you can do with Stata. Again, Stata is a very powerful statistical software. I'm just going to show you a few basic things that it can do really quickly. But again, if you're interested in learning more, please check out the Kipser website as well as Stata's YouTube page and other Stata tutorials where you can learn some really in-depth information about Stata. But for now, let's talk about a simple correlation matrix. In order to run a simple correlation matrix between your variables, you're going to use the pwcore command followed by the variable names of all the variables that you want to see the correlation matrix for. You can also specify star parentheses 0.05. This will give you a star if the correlation is significant at the 0.05 level. So we'll run that command. And so, for instance, the correlation between race and socioeconomic status is significant at the 0.05 level, but this gives you a correlation matrix. We can run a t-test. So say we want to know how math scores vary based on gender. We could say t-test math by the female variable. And run that. And that will spit out information on a t-test. We can run a chi-squared by saying tab to variable 1, variable 2, so in this case gender and socioeconomic status, and we need to specify that instead of just a crosstab we also want it to run a chi-square test, and so that will run a chi-square test. You can specify that you want to see the exact and expected values of that chi-square test if you like, and that will give you exact and expected scores. We can run an ANOVA. So if you want to know how different math scores vary based on school type, or if you just have a dependent or a continuous dependent variable and a categorical independent variable that you're trying to run, we can see how this works and see how different school programs produce different math scores. And of course we can run a linear regression. The command for that is regress. Dependent variable first, followed by your independent variables. So we want to run a regression of math scores based on these independent variables. So we can run that. That will spit out a whole host of information and will give us our R-squareds, our coefficients, our p-values, and a bunch of other information. And we can also run a logit. In order to run a logit, we need to change our continuous math score into a binary outcome, so like a low, high math score. In order to do that, we use the recode command. So we're going to say we want to recode math and make anything that's between 0 and 52.645, the average, the low end of the average. We're going to make that equal to a 0, make everything else equal to 1, and generate this new variable called mathR, which is a dummy variable for math scores. It will generate that new variable, and now that we have that new binary math score, we can run a logit. So we're going to say logit, binary dependent variable, then independent variables, and we're going to specify OR so that we want to see odds ratios instead of coefficients, but you don't have to do that. If you'd rather see coefficients rather than odds ratios, you can take that OR off, and the default itself is just coefficients. So, and again, we have our p-values, coefficients, and a bunch of other information that might be useful. And now that we have some models, the last thing I want to show you here is how to output these results to a table so that you can put it into a paper or a publication. And in order to do that, we'll first run a regression. So we'll run a regression of math on these independent variables. We run that regression. And then we tell Stata that you want to take EST stands for estimates. We want to take the estimates that you just calculated in this model and store that STO as M1. We're going to call it M1. That stands for model 1. You can call that anything you want. So STO, whatever you want the estimates to be called. So STO model 1 M1. So now that stores those estimates as model 1. Now we can run our logit model, and we can STO that estimates, store that as model 2. And then we can use the EST tab command to output a table. So we're going to say EST tab model 1 model 2 using this file name that we're going to specify as workshop-table.rtf. And we're going to tell it to replace any old table that we might have already made. We're going to give it a title called workshop table. And then we're going to label the models, these M1 and M2, as Model 1 and Model 2. If we don't specify this M title, it would just call it M1 and M2. So to look a little bit better, we're going to call it Model 1 and Model 2. So if we run this EST tab, it will run it. And since we specified .rtf here, it will save it as a rich text file. And so basically we can click this right here and it will open up in Word as a text file and give us this decent looking table. And we still need to do a few things to format it, but it looks pretty good. It's not quite publication ready, but just with a couple tweaks, it should be ready to go. Alright. And then last but not least, the last command I would like to show you is this log close command. Remember, all the way back up here, we started a log called workshop log. And so if we close our log, I type in log close, that will close the log. And now this log is going to be saved here in our directory. So we can go to our directory. We can go to the folder that we specified as our directory. I saved it to the desktop, intro to Stata workshop folder, and it should be right here is our log. So we can open this. And here's all the saved output from everything that we just did. All the merge results, all the descriptive stats that we ran. Down here, all the statistical analyses we ran, all the outputs saved right here. So you can always come back and check what you did during this session of Stata. And that, again, will be saved in your directory. And so make sure you specify your directory so you can find your log file. If you've enjoyed this video and have learned something in this video and want to learn a little bit more, I would really strongly encourage you to visit the Kipser website. Please sign up for the Kipser listserv so that you can get our emails and announcements about the fall 2020 workshops coming up and anything that we might have next semester. And if you want to learn more about Stata, you can check out Stata's YouTube page where they have a ton of detailed videos on how to do things. And if you ever have any questions, please check out this do file right here. And thank you for listening. I hope you've enjoyed this video.